Welcome. We are here in France, very close to CERN, at the ADVANTICS office, and I'm here with Michael.
My name is Michalias. I'm CEO of ADVANTICS, and I originally came to this region to work at CERN, as about half of our company did
cool.
before. So I came here around 2012, worked at CERN until 2017, and in 2017 we started our business.
What motivated you to, get out of CERN and do your own thing, and what was kind of the motivation behind?
When I was at CERN, I really fell in love with electric mobility. First e-bikes, then cars, but at first you couldn't buy anything. You could maybe buy a Prius. I didn't want a Prius. I wanted a cool electric car. So I realized the only way to get one is to build it. So I actually built myself a Volkswagen Golf electric with salvaged parts from different cars. And the love for e-mobility and this kind of tinkering brought me into building actual products for these industries.
Oh, that's very cool. And now, that was a while ago, right? Where are you now? What's your company doing? What are you focusing on today?
So we've grown quite a bit since the early DIY days. Now our main business is providing solutions for quite a few industries. Obviously, we did start with e-mobility, where we were providing charge controllers for both vehicles and charging station. Charge controller is basically a controller like this one, where we have some kind of a communication done between a car and a station, because car and the station, they need to talk to each other. They need to negotiate the parameters. They need to negotiate how much voltage you're gonna need, how much current, how long you're gonna be here, and it is a quite heavy communication. So that is what we do for our charge controls. And our other business unit is making power converters, where we're processing quite high power, anything from 11 kilowatts to 6 megawatts. Yeah, we have some of those in front of us. Obviously not 6 megawatts, this table wouldn't take it.
And what's the application for the 6 megawatt or this megawatt charger? So nowadays, where are they used for? Who would buy one? Probably not, not supercharging your Tesla at home, right?
That's right. The 6 megawatt is a bit of an extreme side of the number. Most people, when they say high power charging beyond what personal cars can do, we're talking about MCS, megawatt charging system, and that typically spans from 1 megawatt up to 3.2 or 3.7 for regular MCS, and up to 6 megawatts for really heavy industries. That would be mining, that would be marine, maybe construction, but really the big things.
Oh wow! So you said marine, so it's also on the boats, right? So how does that work, or what's the application on the boat? Probably not cruise boats yet, but
not the cruise ones yet, but maybe we'll get there in the future. We need better batteries for it. But basically, there's a lot of countries that require on ferries for transportation, and ferries, they basically go between one side and another side, and there they need to recharge or refuel, and actually the time that it takes to load and unload, it's enough time to actually charge the ferry. So you can make electric ferries, and that is one of the big applications for marine electrification.
Okay. And then for I know the ferries a little bit from Seattle or so, right? They're close to the city. So a typical city, you have the infrastructure there, so you can add this high power charger, or it normally also includes that they have to rebuild or almost put the power plant there, or how does that work? How does it integrate into infrastructure?
It's funny you mention it, because of course infrastructure is often a problem. Actually, these electric ferries often operate in the Nordic region in Europe, like Sweden, Norway, and so on, where building a bridge would be too expensive. It's not such a high population density up there, and sometimes the infrastructure can take it. If it doesn't, then we also have a lot of projects with battery buffers, where you can put local energy storage and basically recharge your energy storage while the ship is in transfer. So you can then quickly charge the ship.
Yeah, and I think we work together since quite a while, right? You see here some products, many of them have Toradex modules, but maybe you can talk a little bit, how did it start? How did you learn about Toradex? How did you select Toradex?
We actually do go quite way back. I was playing with embedded computing since basically university days. I always found it fascinating to have a computer basically the size of a bubble gum. So I played with different platforms, but when we were deciding which platform to use for our products, obviously we needed something that would be robust, industrial, reliable, long-term manufacturing. So Toradex clicked all of those boxes, not to mention you're not that far from us. That is also a nice plus. And you're not prohibitively expensive. So we said, hey, we have no excuses to not use the good stuff. We could have used a Raspberry Pi or other more hobbyist stuff, as a lot of other companies do, but we said, no, if we do this right.
Yeah, and then also I assume the reliability for you is very important, right? So if I think about a ferry, and you will not be able to charge it, you will make a lot of people very unhappy if they cannot go home after work or, you know, go to their vacation.
That's right. The reliability is very important. And that is a lot more than just about whether it's gonna break. It's really about how the supply chain is handled, whether it's properly tested on the manufacturer level as well than on our level. So yeah, failures are expensive.
Okay. Cool. And what are you doing like on the software side? You mentioned a little bit there's communication, right? I assume if you deal with so much power, safety is maybe a hot topic. So can you talk a little bit what your company is doing on the software side, and then maybe also how that, you know, relates to Toradex?
Sure. So just to clarify, on our power converters, we do use digital signal processors as a direct kind of platform without operating systems. On our charge controls, we use Linux through both on the vehicle side as well as on the charger side, because we do supply both sides of the communication. And there we basically built our own platform on written mostly in Python, but some other languages as well. And we've developed the communication stacks in order to handle the communication. But there is a lot of other things hidden in it, like containers, over-the-air update.
And what you see a little bit on this megawatt charging, where is it growing, where is it going? How do you see the next years for you at the industry?
Obviously, megawatt charging is never going to be as widespread as regular fast charging or even residential AC charging. It is a lot more specialized. But if we want to electrify our logistics chains, like our trucks, our ships, and our construction and mining, we do need to have an infrastructure. Quite often this infrastructure will be specific to the location, like maybe trucks would have megawatt charging at these at different stops in different locations, and then along the main highways. In marine, obviously it's going to be in the port. That one is easy. And for mining as well, like it's actually significantly cheaper to electrify mine than to not electrify it already today.
Yeah. Oh, very, very nice. And what do you see like together with Toradex? How you see the future here?
Well, we definitely continue to work together in the future. We started with IMX6 platform, then we developed some controls on IMX7. Now we use the AM62. So we've been using quite a few different products for different use cases, and we intend to continue doing so. We've been very happy with the platform.
Yeah, right. And I see here you really focus on the Verdin standard, right? Our Verdin modules. So all the platforms you said you basically can move, right? So you also take advantage of the pin compatibility, going up or down in performance and features.
That's right. Or having Wi-Fi or no Wi-Fi, right?
Yes, exactly. Yeah. Great. Yeah. Thanks so much. That's very interesting.
Well, thanks for stopping by.
Yeah. Very nice to see how our products here used in something which also reduces CO2 footprint and really nice our world, I think. Yeah.